Math 3 Lesson Summary Video. Take another spin. This lesson is a solidify understanding task, which takes concepts developed previously and helps you formalize those ideas. The purpose of this lesson is to create three-dimensional shapes by rotating two-dimensional shapes and create strategies for finding the volume of these three-dimensional shapes. The trapezoid shown below is revolved about the y-axis to form a frustum of a cone. So there's a vocabulary word that you want to make sure that you capture, frustum. It's the bottom slice of a cone. If you think about a cone like such, if you were to take it and just chop the top of it off, you would have a flat top and a flat bottom. You would have a circle, and it would have, a flat. So let's take a look at what that looks like here. Remember yesterday we mentioned that the first thing we want to look for is the reflection. We're going to be rotating this one around the y-axis. So here's that line of rotation, the axis of rotation, our line of reflection, and I want to find the reflection. So this one is 1, 2, 3, 4, 5, 6, 7. So I need to go 1, 2, 3, 4, 5, 6, 7. And the bottom one goes down to 8. So I will get 8. And then I have this trapezoid. Now we also mentioned that the second thing we want to do is where we're rotating, we want to find where it's spinning so that we can put in our circles. So there's going to be a circle that goes all the way around like so. So I've got a circle on the top, and then I have a circle on the bottom that goes all the way around. Sometimes, just so I can see things better, I'll shade in one of the faces or one of the sides of a shape just so it gives it a little bit of depth so I can see it a little bit. But this is basically the frustum that we are looking at. We had a cone and we chopped the top off of it, and so now we have a shape. So we've drawn a sketch of our three-dimensional object. We kind of did it on top of our graph, but we want to find the volume of the object formed. Now, there are a couple of different strategies you can take to find the volume of a frustum. One thing to think about is the fact that it is a cone that we have just chopped the top off of. So if we find the volume of the cone and then subtract the piece that we're chopping off of it, then it should just leave us with that bottom piece that's left over. So that is one strategy for figuring it out. Another one is to look at the trapezoid itself and think about the way that as this is rotating around, what kind of shape is it actually making? What you may notice is it's very similar to a cylinder. The only real difference from it being a cylinder is that it's not going straight up and down. It kind of goes out at an angle. What you may notice though is if you cut that side in half, if you were to slice this little bit off right here and then flip that little bit up into this part, we would actually get a cylinder. And this is actually how the area formula for a trapezoid is actually gotten as well, is we think about the fact that this point here, the midpoint of the two sides, kind of creates the little piece that gets cut off of the bottom, flipped up and put on the top, or vice versa, that could actually make this into a rectangle. And then if we rotate that rectangle, we just have a cylinder. But the volume that is created is the same. That volume is distributed differently. It's got a different shape to it, but it is the same volume. And so what we can do to help us find the volume of a frustum, Instead of trying to figure out what that whole cone is and chop the top off of it, we can actually come up with a formula for a frustum. And it is very similar to the formula for the area of a trapezoid. If we actually do 1/2, the area of the top base, because this area is a circle, but the bottom base is also a circle. So we're going to take the average of those two bases. That kind of gives us what is this circle. If we were to take the cross section right here at that middle point, like we talked about, find that circle, because that's the one that if I rotate it around, I'm going to get this cylinder right here that gives me that piece that just kind of flips up. So 1/2 the area of the base plus the area of the base to get that middle circle. And then we want to multiply it by its vertical height, because we learned with volume, all of our volumes, if we multiply it by its vertical height, it's going to give us our volume. So this is going to be the volume of a frustum. And we can use that to find the volume of any frustum, not just this one, but that does actually work for all of the frustums. The following diagram shows the cross-section of a flower vase. Approximate the volume of the vase by using line segments to approximate the curved edges. Show the line segments you used to approximate the figure on the diagram. This is going to be where we develop an idea of finding the volume of a shape by using discs. This is a big concept when you get up into calculus and integration, volume by discs. But we can actually just do it manually and not have to use any calculus. I do not have a volume formula for this type of shape. I just don't. So I'm going to have to find its volume by pieces. And one of the easy ways to take a shape like this, especially one that does revolve, that does have a round shape to it, that does have a revolution to it, is to basically slice that shape into a bunch of discs. And so we can take and we can divide our shape into a bunch of discs. I think I'm actually going to make that one. And there we go. So now if we look at it, in reality, this was a rather curved line. But if I'm going to approximate the volume, I'm going to treat it like it's a straight line. That makes my calculations that much easier. It is an approximation, but it's not going to be too far off. Especially some of these curved lines really are not that far off from the straight line counterpart that I'm putting in. So you can imagine that the volume is really not going to be that different. All right, so what we have made here is a series of cylinders. You know, this is rectangular, so if I rotate it, it's just going to become a cylinder. This one's a nice rectangle. It's going to become a cylinder. And these other ones, 1, 2, 3, 4, 5, 6, these other 6 sections that we've divided up into have become frustums. And so we can actually find the volume of each of these 8 sections individually using our frustum formula and our cylinder formula, and then add them up. And then we can actually find an approximation for the volume of this vase. So go through and see if you can find an estimation for this volume.